Hopefully, this is Karen Rivera. This is the Algebra 2 lessons for IMG Academy Algebra 2. This is hopefully going to help some of those of you who need to review, or while you're traveling and you're at your sports, then you can come back and watch these and know what we're doing in class. I would encourage you to complete this with your note-taking guide that I gave you so that you can make sure you have all of the answers in the note-taking guide. The first thing that we're going to be doing in section 3.1 is we're going to be doing solving systems using graphs. Okay, so that means that we'll be doing more graphing. You're going to want to have your handy-dandy calculator so that you can use it when appropriate, but you definitely want to have it. So for your warm-up, the first thing that I want you to do is I want you to graph each of these equations. You should be comfortable with that by now, but I want you to graph each individual equation onto one graph. Okay? When we do that, we see that they run into, or they intersect each other in a couple of different places. If you'll notice, this line and this line intersect each other right there at that point. Okay? What that means is that that point is a solution for both this equation and that equation. And remember that a solution makes an equation true. And that's what we're going to be looking for, are where are the shared answers. Okay? So this would give us a shared answer for this equation and that equation. Okay? So let's talk about some terms. Systems of equations is just going to be a set of two or more equations that use the same variables. A note to make here is that you have to have one equation for every variable that you have. Okay, so you have to have one equation for each variable. So if I have two equations, then if I have two variables, then I need two equations. If I have three variables, if I have x, y, and z, then I have to have three equations. So we're going to keep that in mind as we go forward. Okay? You have to have a linear system. That's what we call a system of equations when they're all linear equations. Okay? So when the graph of each equation is a line, then that's a system, a linear system. A solution of a system is a set of values, right, in x and y, that makes all the equations true. So where the other two lines intersect and had a true statement, there wasn't really any point for all three of them to intersect. So we're going to be looking at systems with two variables, and then shortly we'll be looking at systems with three variables. But what we're looking for is the values or the points that will make it true. When you get through and you get your system, your answer for your system, you always need to go back and check and make sure that it's correct. Okay, so when we check whether the ordered pair is a solution of a system, all we're going to do is just substitute these values into the equations. Yes, 5 equals 5. And then we substitute it into the second one, because the only thing to prove that they intersect is when that point, 1, 1/2, makes it true. Since it makes this true, since it makes the first one true and it makes the second one true, then we know that it's a solution. Okay, I want you to go ahead and do B. You can stop the video and then come back if you want to do that. Makes both of these true, so now we know that that is a solution as well. When we solve by graphing, what we're looking for is that point of intersection. So you see where well, that didn't help. So do you see where these intersect? That's going to be a solution for this graph. And so that looks like it's approximately -2, -2. So we would test to see if the point -2, -2 is actually a solution. On this one, we can see they do intersect, so there is a shared solution, and it's right here. So that would be an ordered pair, -4, -2. That should make both of these equations true. And it does. Okay, so these I want you to solve. I want you to practice by solving these on a separate sheet of paper, or actually just in your note-taking guide. You can complete this in your note-taking guide. Since there are no solutions in common for C, we say that they're inconsistent, and we'll talk about that in just a minute. But sometimes you have parallel lines and there is no common solution, so that's one type of system that we have. And then in D, you'll notice when you graph it that this is actually one line graphed on top of the other. So they have every solution in common, which means that there are infinite solutions. So your options here are one solution, no solutions, or all solutions. Those are your only three options that you have. Okay, so now let's look at how this applies, and you'll find that linear systems probably have more application to what you do in real life than just about anything else that we're going to do. Mulan and Lilo are competing to see who can sell the most candy bars for a fundraiser. Mulan sold 4 candy bars on the first day and 2 on each day after that. Lilo sold 7 on the first day and 1 on each day after that. So write an equation for the number of candy bars each person sold. Let's look at that for a second. Since they sold 4 the first day and 2 each day after that, 4 becomes our y-intercept and then 2 is our slope. The same thing goes for Lilo, who sold 7 on the first day and 1 each day after that. Okay, so those are our equations. You can see where we got the slope and where we got the intercept from the information that we were given. Now we're going to graph them, and we find a point of intersection. So let's interpret our solution. Our solution is that here at 310, that's going to be a system that's going to be a solution that makes our system true for both of them. So when we do that and we look at it, x is going to equal 3 and y is going to equal 10. So we know that on the third day, they both will have sold 10 bars. Okay? Now, a minute ago we talked about the number of choices that you had for your answers. On your answers, you can only have 3 different options. You can have one solution where they intersect at one point. You can have no solutions where they're parallel, or you can have infinite solutions where you have just the same exact line. If you only have one solution, then we say that they are independent. Think of it as 2 lines that intersect at one point, but they really don't have to have anything else to do with each other. So we say they are independent. Then you could have 0 solutions. Those are parallel lines. There are no answers. They don't care about each other. They are inconsistent. Okay? Then we have infinite solutions where the graphs are on top of each other. Because they share every single point, we say that they are dependent. Right? No intersection at all means that they are inconsistent. If they intersect, then one intersection means that they are independent, and then if they have everything in common, they are dependent. So you're going to need to be able to look at systems and tell me, are they inconsistent, independent, or dependent? So how do we do that? Let's practice. First, we're going to classify the system without graphing. To do that, all we have to do is put them into slope-intercept form. The first one is done for us, so the second one we're going to put into slope-intercept form. Since this equation and that equation, the first equation, are exactly the same, then we know that they are going to be, when we graph them, we'll graph a single line. So we know because the equations are the same that they are said to be dependent. Okay? They are dependent. They intersect on every single point. They depend on each other completely. Here, in a system of equations, let's put them all in slope-intercept form. And we have to do both of these this time. Okay? Notice that my slope is the same. And my intercepts are different. So that means that this is a set of parallel lines. And remember, parallel lines are inconsistent. Means they don't really they do just whatever they want. They don't have anything in common with anybody. Okay, so now I want you to look at your understanding of this. This is something new that we're adding where you can think, where am I? I want you, in your understanding, to be somewhere between the 2 and the 3. Okay? I want you to definitely be able to solve systems of equations by graphing with a little bit of help if you need it. I would prefer that you can do it on your own. And this is going to take a little bit of practice. By the time you finish your practice, you should be above 3 and not a problem at all. So your homework assignment is going to be placed on Orban. It's going to be the practice sheet. And I want you to bring in on Tuesday, Monday or Tuesday, when you come back to my class, I want you to bring your note-taking guide and your practice sheet. If you didn't get a note-taking guide, you may not have gotten one Thursday in class. If you didn't get a note-taking guide, just bring your notes so you can transfer them and then your practice sheet.